Welcome, everyone. We'll give everyone just another minute or two to join, and we'll go ahead and get started. All right, let's go ahead and get started. So I'm Ryan. I'm the product team here at Observe IQ. And if you've been following along, this is our Mastering OpenTelemetry series. Hopefully you've been enjoying it so far. Today, Mike's going to walk through building an observability pipeline with OpenTelemetry. So we'll start to get into the weeds on actually building out some pipelines. This is the fourth webinar in the series. We've got a couple more left after this, one on instrumenting your code base, and then finally managing really high volumes with OpenTelemetry. So with that, I'll hand it over to Mike, and we'll get started.
Thanks, Ryan. Thanks, everyone, for joining again. One thing to mention, I guess, if you have any questions along the way, feel free to just drop them in the chat. We'll try and answer those as we go. And if not, we'll answer them at the end of the webinar. So just a couple things, we'll jump right into it and get into how to build a open observability pipeline with OpenTelemetry specifically. We'll talk about what that means, because there's a lot of different definitions of observability pipelines these days. So talk about what we mean when we say that, talk about the architecture, some configuration details, and then finally show an example of building out a pipeline using bindplane. So first, I just want to talk about what an observability pipeline is. And sometimes they're called telemetry pipelines, observability pipelines, and it can mean a lot of different things. For the sake of this discussion, what we're talking about is really a framework or set of tools that manage collection, normalization, processing, and routing of all your observability data. So that typically that's going to be logs, metrics, traces. Could be other telemetry data, and it's going to route that to the correct monitoring, analysis, or storage systems. So it could be APM, could be security, could be cold storage like S3, or other buckets. And if we break it down to individual components, collection is probably obvious. The collection is what you get when you deploy an agent anywhere. And that by itself is not an observability pipeline, but that's really gathering the telemetry, logs, metrics, traces from applications or servers or network devices, really anything in your environment that you want to monitor, manage, or understand better. Then there's a normalization component, and this is key. It's the pipeline is standardizing all that telemetry to a common format. So rather than sending it in a dozen different formats, you have a single standard that you're using. It simplifies the processing, it simplifies the environment in general, and allows you to standardize on a single type and then process it in the same way. And then there's processing, which can include a lot of things, but the most common are filtering, maybe filtering out data that you don't need. Could be aggregating data, transforming it in various ways, enriching it by adding additional tags or metadata to the telemetry as it's passing through the pipeline. And then routing, which is getting that telemetry once it's been processed to the destination that you need it. So it could be an alerting system, your monitoring tools, really anywhere. But those four components build up the pipeline, and that's what allows you to standardize everything on a single structure. And then it allows for the other two, which are scalability. You can handle high volumes of data with a model like this. It's easy to adapt if you have new changes, whether it's new sources coming in, new destinations that you're intending to send the data to, or you come up with new ways to process the data in the middle. And then it's more reliable and more efficient. So this is designed to be resilient against failures. And it's more resilient than individual agents running and sending to a single endpoint. So the intent of this is to help with all of those. Not every pipeline is going to need to include each of those components. When we really thinking of it holistically, this is what we're talking about. So in the context of OpenTelemetry, this is a very simple observability pipeline. I want to call out a couple of the components here. First of all, we're talking about the OpenTelemetry collector as the key building block of the pipeline. And we talk about it in a couple of different modes, both agent and gateway, and typically limited to those two. But it's important to understand it's the same collector, and typically you're using the same binaries for this, unlike other structures where you may use a specific type of collector for the gateway processing. This gives you the functionality. You can use the same functionality, whether it's deployed on your host next to an application, or whether it's a dedicated system or scale out where you're doing your gateway aggregation. So it's a key to understanding. It gives you a lot of flexibility, but then you have a lot of decisions to make. And so there are some good general best practices you can follow in terms of where to put the processing, where to put different parts of the pipeline. And that's where we think of the separation of responsibilities between the gateway and the agent. Typically at the agent level, this is going to be similar to what you would have with any agent for an observability platform. So it's going to be focused on collection, any pre-processing or caching that you want to do on the application host. And then it does some level of normalization, right? So certainly with OpenTelemetry, the normalization is it's converting anything that's gathering into OTLP. And that's going to be the standard format that's used throughout the pipeline. At the gateway level, this is really focused more on processing. So a lot of the processing that you're going to be doing, if it's computationally heavy at all, or if it's normalizing the data in a different aspect. So think of it as you're adding in application tags. So if it's coming from a certain group within the organization, you may want to tag that in a specific way. That's another type of normalization that would happen at the gateway level. It's also responsible for primarily for all the routing that's going to be happening within the pipeline. So the agents are sending to a gateway, and the gateway can then decide where do we want that to go. And if we add a new solution, if we add a new option for analysis, it's easy to make that change at the gateway level, and then you don't need to roll that out to all the agents in an environment. Also talk about the scalability and load balancing. The gateway level is typically where you're going to scale out. So because it's a central location, and there could be many of these, but in this diagram, we're only showing one gateway. It's simple to add a load balancer, just like you would in a typical application scale out. And that allows you to scale this out really as much as you need to. So simple load balancer in front of your gateway, that's what really unlocks the scalability component of this. And then that can be used over as many gateways as you need, and these can string together. So in here, we're showing one gateway, it's gathering data from, in this case, something that's non-OpenTelemetry. So if you have legacy deployments and you want to pull them into your OpenTelemetry pipeline, you can do that as well. But these gateways can string together. They can have multiple responsibilities along the way. We'll keep it fairly simple in this case and say we have agents going to a gateway that's doing the processing and that's sending it to the destination. And then the last component of this with OpenTelemetry is the OpenTelemetry management protocol. and that's op-amp. This allows you to manage your OpenTelemetry collectors, manage the configuration. And when this starts to get very large, that's an important component to be able to see your observability pipeline or your telemetry pipeline at scale and understand what's happening at each stage. And that's something that if you've been in some of the other sessions we've had, it's something that's newer. We'll show an example of that in Biplane later on. But what it allows you to do is visualize and change configuration, update collectors, and then understand everything in a holistic way. Before we jump into the next piece, just a quick reminder, and this can be a little bit confusing, right? When we're talking about observability pipelines, because the OpenTelemetry collector has a concept of pipelines within it. And that pipeline is made up of receivers, processors, exporters, and others. But we want to talk about how each of these components might be a little bit different depending on whether this is an agent, whether it's a gateway, or the location within the architecture. And so now if we're thinking of the agent specifically, and this is deployed typically to a host for a specific application, maybe it's within a cluster, but the key purpose of this is it's at the edge and it's collecting telemetry. This is going to be very dependent on the system that you monitor, the receivers that you're going to be configuring. And so I won't spend a lot of time on that, but typically things like, host metrics, whether you're pulling in raw logs from an application, traces from a custom application, specific, packaged application receivers, or even OTLP as a generic input into the receiver. Those might be some common ones, but that's going to be very dependent on what the workload that you're running. When it comes to processors, though, we can put in place some recommendations. We can say it's really common to have a batch processor. It's very common to have resource detection. So actually detecting the type of host that you're running on. If you're running in a cloud, it'll automatically detect information about those instances. It's common to have some basic masking and redaction at the agent level. So removing any PII or details you don't want further through the pipeline at the source. And then I'd say sometimes particularly if it's something that's a mission critical application and you have an agent deployed on that same host, you may put in some additional checks like a memory limiter just to verify that you never accidentally go beyond what's expected as a collector. I'd say this tends to be pretty rare. I think as long as you're doing some basic benchmarking, you should have a good sense of what the maximums are going to be from a deployed OpenTelemetry agent. But that is an option, and it's sometimes recommended as part of deployments. Then I'd say use case dependent, but you can also include things like transformations, filtering out or reducing data. But really, you have the full spectrum of processors available to you at the agent. I'll say in this architecture, really thinking of this as the agent is going to do minimal processing, and then it's going to push the majority of that to the gateway to handle the bulk of that. Then the gateway can scale out and manage it if there is a lot of processing to be done. On the exporter side, this is maybe the simplest, because if you have an agent within a pipeline, you're just exporting OTLP. You're exporting it to a gateway, so you configure it for your gateway endpoint. And then throughout the pipeline, you've standardized on the OTLP protocol, and that's what you'll be using throughout. So even if you had 4 gateways chained together, it would be OTLP exporters and receivers for each of those. The last thing I'll mention is agent data queuing. Now, part of the resilience of this architecture is that you can put in queuing at each stage. And again, it depends on your requirements and how critical it is for certain applications. But this is something that you can standardize throughout. So if that is something for certain applications that is critical, then I'd recommend adding the storage extension and then including that in queuing data. Now, absolutely, we recommend doing this at the gateway level. I would say it's an optional component at the agent level. So jump into the configuration of the collector as a gateway. And again, the basics of this can be simple, and that's because OpenTelemetry was really designed for this purpose, with this purpose in mind. The configuration is going to be a receiver for OTLP, all of the processors that you are expecting, and then exporters to, in this case, your end destination. So that could be an APM platform, could be a SIM, really could be cold storage as well. But the core piece here is in the processors. And so for receivers, we're often only going to configure an OTLP receiver. We could do multiple OTLP receivers, and I can show what that looks like in a minute. But with the processors, that's really the core of this. Again, with extensions, we recommend implementing caching here, and that's something where we can be a little bit more flexible with resource usage, because at the gateway, we're going to implement a scale out with a load balancer in front of it. And then the exporters, of course, these are just going to be dependent on the destination. And scaling out a collector is really straightforward. This is just like if you were scaling out an application, we put a load balancer in front of it, and then we allow it to scale out based on resource utilization. This is something that in your environment, based on your use case, you'll want to look at, but a good starting point is just to set this at an 80% of CPU or RAM on all the nodes. And if those are start to creep above 80%, then you'll want to increase or decrease based on that. For up detection, we use port 8888, which is the collector's Prometheus metrics port. It's just an easy way to know that everything is up and running. Your pipelines within the collector are ready to go. And you can use that to validate that a new node is ready to receive traffic. So very straightforward. And, the challenge really becomes when you understand how all of these pieces fit together, it's then how do you manage it? Because, deploying these in a handful of them, configuring them in a gateway formation is fairly straightforward. When you're dealing with 1,000 or 10,000 or 100,000, that's where it can get complicated. And so that's where we're talking about the Open Agent Management Protocol as a way to manage your telemetry pipelines from end to end. And so I'll jump into a demo of this. It's using OpenTelemetry for all of the collectors, whether it's an agent or gateway, but it helps visualize it. We'll do this with BindPlane. It is a native op implementation. It's using the ObserveIQ OpenTelemetry distro, and it has some additional functionality designed to make it easy to visualize and see and manage this at scale. So let me pull up BindPlane. Okay, so we'll go through and build a observability pipeline with a gateway and then a couple of agents. And just to orient you to the platform, this is a high-level overview of all the agents that we're managing today. The configurations, this is a single OpenTelemetry configuration that we're applying to 25 agents, sending data to Grafana in this case. And we can measure the throughput, the volume of data that's passing through. What we want to do is we want to start by creating a configuration for a gateway. So we can, within BindPlane, we can create the gateway configuration. We can choose it for Kubernetes if we wanted to, Windows. I'll stick with Linux for now. And like I said, so with the gateway, we're going to be ingesting OTLP. So I'm just going to add one OTLP receiver to start. And then for a destination, I'm going to send this, in this case, we'll send it to a Splunk environment. Okay, so now I have a basic OpenTelemetry configuration that has an open or OTLP receiver, and it's sending to a destination. I can look at the configuration and see the different components of that. There's my OTLP receiver. I have batch processor that's automatically added. I have resource detection included in there as well. And then an exporter set to send to Splunk Observability Cloud, then the pipelines that are built behind the scenes. So I have this ready to deploy, and then I can just add it to agents. I have a raw configuration now. I have a number of agents that are available to me. I can deploy it to any of these. I have one configured already. I'm going to go back to this gateway example that's already loaded and running in just a second. That gives you a sense of how you get the gateway configured before you add any processing, and then have this to deploy to a host. So that's the first piece, and the second piece will be to add at least one agent configuration. We'll do this again, choose Linux. Now this is where the sources are going to be dependent on the systems, but frequently we'll want host metrics. You can choose what's relevant to us here. Maybe I want CPU and load. Then if we have any workloads, we can choose from the receivers available within OpenTelemetry. I'll choose Postgres in this case, and we're only going to look at logs, Postgres. So a couple of simple receivers, we could add as many as we need to. And then just getting started, we'll add one destination. In this case, again, this is the agent. So we want this going to connecting to the gateway. So we'll choose OTLP. I have one configured now. Choose that gateway. And now again, we have a really simple configuration. And if I look at the configuration file, I can see we have our host metric receivers, all the configuration details there. We also have Postgres log plugin, and it tells it where to look for those Postgres logs that was pre-configured, and it knows the default location for those log files. Automatically include the batch processor, resource detection, and then the exporter is going to an OTLP endpoint. It knows the location because that was pre-configured. Then it has some additional things like the queuing, retry, and failure. You can see that we have file storage enabled, so it will queue, and you won't have any lost data within the bounds of your sending queue here. And then the pipelines are automatically built. So this is also ready to deploy now. We can add this to an existing agent. We'll add it to one that I have available here. And then when we add this to an endpoint, it's using op-amp to connect to that agent, which has a connection back to bindplane, and then push down the latest configuration. So if I take a look, this is ready to be rolled out, and this will push that configuration down to the new agent that I added to it. I have an error. I may have picked the wrong agent for this one. So I'll jump back in and look at one that we already have configured. So here's one that has a number of, or is deployed to a few agents. I have this to 2 agents, deployed to 2 agents right now. It's a Windows system. And it's gathering host metrics, some IIS logs and metrics and Windows events, and sending them to a couple of destinations directly. So this is a configuration for a collector. It's really an agent mode only, but we can really easily redirect that traffic to our OTLP endpoints. So I'm going to choose this gateway here. I'm going to remove these. So I was sending to Google directly, was sending to Splunk directly. And I'm going to change that so it's sending to my gateway. And so this will take a second. We'll try that again in just a second. But what we're doing here is we're changing this from those two destinations, the Splunk and Google, to the gateway that we have reconfigured. So we're reconfiguring everything within the pipeline so that it's rerouting it through our gateway as opposed to directly to the destinations. And so now if I go to the gateway, this gateway that we had, I have a couple of things that I've already configured. So I have this OTLP receiver. It's receiving data from the agents that I just deployed that to. It's going through a couple of processors and that's sending that data to Google Cloud and Splunk. And so I'm ultimately replicating the path of the data. So I have agents sending to a gateway now where I can do the bulk of the processing and then sending to a destination. When we go into here and look at the processors, we'll look at a different one, some data flowing. Let's try. Okay. So here's an example of an environment with data flowing. And so just like you could with the gateway or at the agent, we can now start to apply processors to reduce data, augment your data, or make changes in real time. We also have a new feature that will review the data that's flowing through and give you a recommendation on best practices to apply. So before I do that, I'll show you what we have here. This, if we look at the underlying OpenTelemetry configuration, we have the host metrics receiver configured for those specific metrics. We have batch resource detection, and then we have exporter to Splunk. But now we want to apply some additional processing. So we'll take a look. We have a recommendation that says that if you delete empty values, I'll show you what that means. It'll likely reduce your total volume by 7.7%. So I can view that. It's going to remove any null values, any empty lists, any empty maps. And frequently this is a source of unnecessary data as you're going through a pipeline. So we'll accept this. And this is something that makes a lot of sense as a processor within a gateway. Strip out all the unnecessary fields. You can add any additional metadata you need and then route it to the correct destination. Beyond this, we can also do things like deduplicate logs as they're passing through. We talked about deleting empty values already. So it's recommended. Also filter by metric name or severity. So filtering by severity is frequently useful prior to sending to specific, maybe expensive destinations. So within a gateway, we would use a processor like this to remove any maybe debug or info level logs before we send it to the final destination that may only be concerned with error messages or critical messages. And then because we're routing, we can also route it to route the full set of data to lower cost storage. Discard that and show you what I mean. So right now we're sending all of this data to Splunk, but maybe we also have an S3 bucket that is our low cost cold storage. And so we can go in and filter out things like the empty values. And we can also do things like deduplicating logs. And we can add some additional filters. I'll do something like sampling. So maybe we only need a sample of this particular type of log. And these are all processors that you can use within an observability pipeline, and typically you'll be using at the gateway level to reduce the amount of the volume of logs being passed through. So I'm going to save that and roll that out. And in a minute, we'll get some of the throughput values. But if you look at the diagram, it shows you in a way that's maybe easier to see. We'll look at the configuration in just a second. But it's collecting logs and metrics. They're being then sent to both Splunk and to AWS. But we see we have filter processors prior to those being sent to Splunk to reduce the amount of volume of logs, metrics, and traces that we're sending. And this will start to get a bit more complex. We have the receiver for host metrics. We have our Postgres source. Again, batch and resource detection. We have exporters to S3 and then also Splunk. And you'll see the specific processors that we're applying. And once this is rolled out, you'll see the individual processors that we applied, like removing empty values, and some of the others that were included. So go back and take a look. Looks like I may have an issue in my demo environment, so we won't be able to show that piece. But in just a second, you'd see that the total amount of data is going to be filtered out through the endpoint here prior to going to Splunk and reducing that significantly. And so when you're configuring a pipeline, go back to what we talked about here. What we're really looking to do is to push most of that processing to the gateway. So maybe in the past, you had agents deployed. They may or may not have been doing this type of data reduction or routing. But by moving it all to the gateway, we've really standardized and simplified our environment and can process things all in a very consistent way. I'll say one additional area that a lot of our customers are using a gateway for is in the standardization or normalization, but in a specific way. It's really focused on if you have a number of teams and say you are within the observability practice within your organization, you have a number of different teams and they are all conforming to a standard. You give them an endpoint, this gateway, they are building their own applications. They're sending telemetry, the telemetry that they believe is critical for them. You can provide them with a format. They'll send it to your gateway that you're managing. And then you can validate that the data is in fact meeting those required parameters, and either simply drop the data that's not, or you can do things like augment it. So if it's missing a certain field, you can apply that field within the gateway. But this structure allows you to do that and help to validate that you have clean data prior to sending it to the destination. So let me check one more time if I can get some data reduction on this one to visualize. Metrics. I think it may just be that I'm not sending the logs to cloud. So I'll pause here and see if we have any questions before we move on.
Yeah, Mike, we do have one question unrelated to kind of everything you're showing today, but are we hiring for OTel or data engineers?
We are actually, yeah. So we'd love to hear from anyone that is interested in OpenTelemetry, is working on OpenTelemetry. at ObserveIQ, it's a big focus for us. We've been working with the OpenTelemetry project for over 2 years now. We donated the log engine component of it, and are very invested in that. And we think that I think OpenTelemetry is really the path for standardization across the industry. And we think customers and other vendors are starting to believe that, are starting to deploy that and starting to implement that in practice.
Great. We've got one more question that came in, Mike.
Yeah.
All right. It's a long one, so just reading. One sec. Can the agents know multiple gateways and change route if one gateway is not available? Sort of like a high availability gateway. That's question one.
Mm-hmm. Yeah. So, and in a typical, load balanced architecture, you would really see that. Can the agents know that individually? There are mechanisms you can use to have like a fallback. Typically, the way that we would do it is just rely on a load balancer as opposed to multiple and then validating whether or not that's it's active. But there are options. There is a high availability option within the collector. I'd say that for us, we found best practice has been just to use load balancers. It tends to be simpler for teams to implement that are already familiar with more of a typical architecture.
Great. Can we use gateways as a source of VIP/endpoints that can check the destination for availability? So say there are 3 nodes, check the heartbeat to send data.
So the gateway would be, I'll have to follow up on that one. I'm not quite sure which point we're looking for the heartbeat to send the data. I can say that, for any of the collectors, you can do things like you can self-monitor. So you can look at whether it is active and whether it's healthy. And there are endpoints that you can configure. We mentioned for the up validation when you're doing auto scaling. We use the Postgres or Prometheus endpoint and just check that to validate that things are up and running, since that's a default enabled on the collector. There are other health check options that you can use within the collector, though. So likely what you're looking for can be worked out. I just don't quite understand the structure of it.
And I captured the question in detail, Mike, so we can look at it and see if we can follow up with you more directly. A few more questions if you want now, Mike, or we can wait till the end.
Yeah, let's just go through those.
Okay. Is there a rollback option available so that if multiple configs fail, it can roll back to a previous version?
Yes. So we do have rollback available, and you can go through the full history of a configuration. So a good example here. So you can go through view the one here. But within BindPlane, we do store the history of all of your configurations that allow you to roll back to an item that's available. So you can see this has quite a history. I've been using this in the environment for a while. You go to an individual version, you can see the differences between them. And that's useful when you're validating. I'll also mention that one of the ways, say most customers use this, is when you have a larger environment, you may have specific folks in your team that are authorized to do the rollouts, to make the changes as an additional validation step. And so you'll have team members that may update, and they may change processors or add additional receivers or sources. They'll stage them, and then we can have someone who is an admin on this come in, validate those changes, look at the specific updates before deploying anything. Similarly, we can handle that within a GitOps workflow. So some folks prefer to have all of their OpenTelemetry configurations for agents, gateways, and other checked into a repo, and then making changes either in BindPlane or in that repo, and then deploying them on a pull request. So that's just another layer. It really depends on what your workflow is, but nearly everything that you see here can be done through a CLI or API. So it can be automated and fits into your existing automation.
I'll add too that we also protect against deploying failed configs. So when you initiate a rollout, if there is an issue with the config, we'll catch that and pause the rollout, so it doesn't deploy to all your agents. It gives you time to edit it, make some changes, and then redeploy.
Yeah, and you saw that live. So if you make an error in a configuration, or you configure something the way you shouldn't, it's going to prevent that from going out to all of your systems. So it's always validating before it will continue. And typically we have validation here as well, because we're putting guidelines into what can be accepted. If you add a processor, this can be a very something that can be very error prone. But if we're we provide it here, we build it based on what you're entering, and so it makes it much more difficult to put in a configuration that's not valid and deploy that out to your agents.
If BindPlane does not have a specific OTel package, how can I add one to a BindPlane agent?
Yeah, it's a good question. So today we have, I would say, the majority of the core OTel components that are official. If you want to add an additional, we're actually working right now to support customer builds or customer builds. So we would just require that you have some of the specific components that we use with BindPlane to manage. And as long as you have that, then you'd be able to bring your own collector. Something we talked about last week or the week before is building your own using OCB to do that. We're working towards having BindPlane fully support that, and just allowing you to select the specific components. As long as you have op amp and a couple of other components that we require, then it'll be supported. But I'd also say, if there is something that is a package that you find useful, we'd love to hear it. We do tend to add components on request pretty quickly. And so if there's something that we think will be valuable to a number of customers, we'll include it in our next collector build.
Awesome. Let me grab a couple more real quick. By sending all the data to the gateways, are you not overloading them and underutilizing the agents?
Yes. So that's a good question. It depends, is really what it comes down to. This is where, because we have so many, you really have the full range of options. You can do all of the processing at the agent level, or you can do all the processing at the gateway level. Usually the trade-off is how much capacity is available at your endpoint or at the edge. So if you're running collectors on systems that have excess capacity, then I would say it's very reasonable to do some processing on those as well. If your concern is more that you want the absolute minimum impact on your edge systems, or on the actual application host or the cluster that you're running your application on, then we'd recommend moving that to the gateway. So you have the option to do either. What I'd say is, if it's key that you remove all processing from the agents, then the gateway is an easy solution, and it can be optimized fairly well. You're scaling out with just the resources you need to process that data. So it depends a little bit on your architecture, but I don't know that you're overloading them as long as you're scaling out. I would just say it depends on the architecture of your environment.
All right, two more, Mike. Do you have a suggestion for simple storage? Uh, I guess what is best to use, S3 versus alternatives?
Yeah, I wouldn't recommend any particular one over the other. I think again, at this point, uh, I think they're going to be very similar in a lot of ways, and it really comes down typically to what you're most familiar with. So if you find that you're using S3 and you're comfortable with that, then I would use that for cold storage for telemetry. If you're on Azure, if you're on Google, they're all very reasonable options at this point. There's not going to be a big difference between them. So it depends on what your specific use case is, but I won't recommend cloud or specific cloud for that. I can say that they all work well. So if you're looking to store telemetry in say a bucket, you can really do that just about anywhere. And then depending on what you want to do with it after, you may look at the specific features of the cloud vendor that you're working with. So some people, in one of the examples I gave of sending full fidelity data to S3 in that example, that means everything is going to S3. It's going to be fairly low cost, cold storage. And then a portion of that data, maybe half, maybe a third of the data is going to Splunk. Now it could be Splunk, it could really be any other vendor. But the key thing is you have that full log. You have all of your metrics available in the bucket. And so if you need to go back and analyze what happened or any of the issues that you encountered, you can use tools within AWS or within Google Cloud or within Azure to scan those logs. And so looking at the functions available there, that may be a way to decide between the storage if you don't already have a specific cloud that you're using heavily.
Awesome. And then the last one, I know we've already seen this a little bit, but it might be worth diving into some more. Can we see some sample data in bind plane while data flows from source to destination?
Yeah, I can pull one of those up. So here's an example of this is an active fleet of collectors. And so what you're looking at here, I'll pull up the configuration. This is a fleet of Nginx instances, and we're collecting metric and log data from those Nginx instances. And then standard batch resource detection running on GCP or Google Managed Prometheus, and then exporting to AWS, exporting to Google Cloud. So if we look at these, we're seeing the data collected and then running through processors and then being sent to Google Cloud, AWS, and then Google Managed Prometheus if it's metrics. So I can switch between different views for metrics, logs, and traces. And this, one thing to remember is this is deployed in this case to 21 separate hosts, so 21 separate collectors that are running somewhere in your environment. And this is representing an API endpoint that's scaling out. So when we go in and we want to look at the sample data, what this does is when we click into a processor, it's connected to one of those agents, chooses one at random, but we can choose one specifically. Look at all the agents and how much data is flowing through them. And then it pulls a snapshot of that data. And this is really helpful when you're trying to determine how can I process the data and either reduce or add additional values. So I can see in this case a warning log line. I can also go and look at the metrics that are coming through, but I'll stick with logs for now. If I look at this error message, this is a standard OTLP frame. So we have a body, we have the attributes. You can see that we have components that have been added on here, things like the remote IP. That was likely from the resource detection, the host name, the OS type. all that would have been added when we did the resource detection earlier on. And then we can do things, the processing on this data. So I can even choose an attribute specifically. I don't want things like this request refer. Let's just try accepting deleting empty values. So we get here. All right, so now I see an error line on both sides. I added this delete empty values processor. What it's looking for is things like a hash, something that indicates there's no value here or null values. And so I can see on the left, this was my input log. And on my right, this is the resulting log message. And so I removed those, removed the host attribute, removed the user attribute that didn't have any additional data in it. Now I'll show masking sensitive data, I think is another good one to take a look at. This is masking out information that you may not want sent through gateway or sent to the destination. So we add in some of this. Sorry for this. If we add in some of this processing, you'll see that the request remote IP has been masked, and we just get the masked value here. So we're going to remove any data as it's processing through, mask out anything that we were showing in this masking sensitive data, things like credit cards, date of birth, but you can add in your own regex to identify specific data that you want to remove. So I'll jump back and save this. So hopefully that gives you a sense of looking a little bit more closely at the data that's flowing through and how you can view it within BindPlane. And that's one of the features of BindPlane. We use OpAmp to connect to agents. We can pull snapshots of that data so that you can act on it directly. Otherwise, it can be kind of challenging. You know, I've showed you the process of doing that from a configuration file, but figuring out and validating that these rules are working for you, for example, that you're removing the empty values correctly, can be challenging without that real-time feedback. Maybe one or two more questions before we wrap up.
Yeah. Was there anything else you wanted to show off in the webinar right now?
We're just about wrapped. So I think
okay. Cool. Will alerts be sent out if any of the agents are offline?
So we can add in as a piece of this, just like you add in other sources, we can add in additional monitoring capabilities. So you can look at the BindPlane instance. We can get metrics or logs from that. We can identify it as a BindPlane gateway, and that gives you some additional functionality. So from here, you can set up monitoring and then send out health heartbeats or health metrics. And that's typically how we recommend that the users deploy that or identify if something's offline. So you have a heartbeat that's flowing through your normal pipeline at your analytics endpoint. You would then be watching for all the collectors that are critical for you. If any of those go offline, then they go through your typical alerting system.
Great. All right. Any last questions? Is there role-based user management?
There is, yeah. So for one of the use cases I was mentioning earlier, we do have role-based access control, multiple levels, and then that's primarily for user management, but then also for things like limiting the ability to deploy configuration to any of the instances. So you can provide certain users with view-only access, so they understand what's happening in their environment. Some can have edit access, but they can't deploy, so they can build out configurations or make changes, and then they have to be validated by an administrator. And then, of course, someone that has full control to deploy those. And some folks, if they want even more fine-grained control, will then move to a GitOps workflow and then limit the access to specific configurations to specific groups within the org.
Is it possible to auto instrument OTel to apps via bind plane?
So we can't auto instrument from bindplane, but it does support auto instrumentation. So we can, if you have, or if you're using an auto instrumentation package, then we can pass that through a collector, and then it goes directly into your pipeline, just like any other traces. I'll say that we do add functionality. We've been adding a lot of pretty interesting new functionality pretty quickly. So keep an eye out for the updates that we send out. And there's a good chance that something that you've asked for will be on there in the coming months. But I guess as we're about to wrap up, just wanted to mention we're doing a couple more of these. And I'd love to hear any feedback if you have it, or if there's anything that you're really hoping to see in a series. We really love talking about OpenTelemetry. It's what we do day in, day out, and love hearing feedback from folks. So next couple, we're doing instrumenting your code base with OpenTelemetry. Talk a bit about auto instrumentation as well. So it's probably one worth looking at if that's interesting to you. And then managing high volume with OpenTelemetry. So what does it look like at an individual agent and gateway level, and how do you handle it when the scale and the volume gets really high? And we have some customers doing pretty incredible volumes of data at this point, so have a lot of experience with that. All right, I think that's it for today, but hey, appreciate all the questions, and I appreciate everyone joining, and look forward to seeing folks next time.
Thanks, everyone.
Thanks all.